Hello viewers, Ved here. So in the today's video, okay, I'm going to start you can say kind of a fresh playlist, okay, which is going to discuss all the problems that has been given in the SS Krotov, which is a very famous book you can say, which mostly like the JEE advanced people who are preparing for the JEE, they also refer to that book, and whoever is also preparing for INPHO and IPHO, of course, they also go through that book for the problem solving. Okay, it is very elegant book in terms of problem solving in my point of view, and of course all the other teaching fraternity and as well as what we can say the student community also, they like this book. So without any further ado, I'll start with the first problem of the book, okay, and we'll see the more and more number of problems of this book, and of course the more upcoming books that I'm going to discuss is going to come. So stay tuned, okay, and you are going to see a lot of problems and the discussions of those very good problems on this channel, okay. So let's start guys. So first let me formally read this problem, and then we'll see that how do we solve this problem, okay. So problem says like this guys, that a body with the zero initial velocity moves down to an inclined plane from a height h and then ascends along the same plane with an initial velocity such that it stops at the same height h, in which case the time of the motion is longer, okay. So guys, if you see what I'll do first, we should just a minute guys, let me. So guys, the first thing that we should do is we should draw the figure of the problem as we read the question, okay. So if I read the question, so it is saying guys, like let's say we are having a inclined plane, okay, and the height of this plane is what, h, and let's say this angle is what, theta. That's my assumption guys. So that when a particle is going to drop from here guys, it is going to slide and it comes, let's say, up to this, okay, and when it reaches here, let's say this distance is what guys, for the calculation purpose, is what, L. Then it takes, let's say, some time, let's say how much, this is I'm calling t down, okay, t down. And again guys, what you have to do, you have to throw this particle, you have to throw this particle in such a way, you have to give such velocity so that it reaches what, to the same height and stops for a moment, okay. So momentarily it is going to stop. So this time is going to be what guys, let's say t up, okay, t up. We can write also t descent and t ascent, okay, but let's say this is t down and this is what guys, t up. So the question is asking that which one is greater, t down or t up, okay. So that they are asking in this problem. So guys, see, when we read this question, there are two types of possibilities might comes in our mind, okay. The one possibility is what, that maybe friction is there, maybe friction is not there. So guys, if you see, if friction is not there, it is very obvious that whatever the time will be taken in the descent, the same time will take in the what, ascent also. So this is a very normal thing. You will say, sir, how? So it is very obvious guys. If you see, the g sine theta, which is your acceleration, is going to be downward, and the same will be guys, what is going to be retardation if you throw, so that it will reach up to what, the same distance, okay. So of course the acceleration will be what guys, sorry, d acceleration will be what in this case, g sine theta in this direction, okay. So of course if we do the math, we will see that the time is going to be what, same, if you want that the particle just reach what, at the height, at the height or that distance from where it has been what, left, okay. So guys, it means what, it means that this problem is not about what, the frictionless surface, it is more about what, the general situation, means that surface is what guys, surface is having some sort of roughness, okay. So assuming that, let's say this roughness is what guys, is constant, okay, assuming that this roughness is what guys, constant, and if this friction is there guys, okay, so what we can say, we can say that if this body is sliding down, if this body is what guys, sliding down, what we can say, we can say that it will go down like this, okay, and if it is going down, then in that case the acceleration that particle is going to have guys, because if you see, because body is sliding down automatically by itself, there is no force we are applying, it means that guys the g sine theta is greater than what guys, mu g cos theta, okay. So it means what we can say, let's say we call this as a1 and this we will call as what guys, a2. So what we can say, we can say simply that uh, a net guys in the down, or we will call like this, a down is going to be simply guys what, a1 minus a2, okay. So that is going to be the magnitude in this case. So with this idea guys, what I can say, I can say that the v square, okay, sorry, the time taken guys, okay, the time taken t down for this distance l to cover is going to be how much guys, if you see, because it has been dropped from the rest. So l is equal to what guys, it is going to be, u is 0 guys, so I can directly write half a1 minus a2 into td square guys. So t down I am just writing with the subscript d. So guys we can say that the td is going to be how much guys, it is going to be 2l divided by what, a1 minus a2 square root, okay. So this is going to be the guys what, time when it is has been you can say descended, okay. Now the second possibility which we have to talk about is guys what, when it is going to be ascent, okay, and it has been what guys, going up. So when it is going up, in that case guys, in that case if you see, the velocity that we have to give is that much, so that it can just reach up to what, it can just reach up to what guys, this height, okay, it can just reach up to what, this height, that is our target, okay, that it should just reach up to what guys, the topmost point, okay, from where it has been dropped. So it means guys its velocity is going to be what, 0 when it is going to reach at that point. So guys, using the idea of v square is equal to u square plus 2as guys, if you see, let's talk about the acceleration first. So guys if you see, a up, okay, a up if I talk about, so guys when your body is going to go up, when your body is going to go up, at that moment guys friction will act downward, and g sine theta means your gravitational force is also guys, the g sine theta component, mg sine theta component will be what guys, also acting in this direction. So what we can say, mg sine theta and plus mu mg cos theta both will be acting in the backward direction guys. So it means your retardation in that case is going to be what guys, minus of a1 plus a2. So guys what I can write here, I can write this is going to be minus of a1 plus a2. So with this idea guys, what I can say, I can say that final velocity is going to be 0. So v square is equal to what guys, let's say we give some initial velocity so that it can reach up to that height, minus 2 a1 plus a2, because retardation is happening guys, so this into l. So guys this is going to be what, 0. So what we can say, that u, sorry guys, the u that we are going to have is nothing but what, it is under root of 2 a1 plus a2 into l. Now guys because we got u, we can find out now time very easily. How guys, we know that v is equal to what, u plus at, and because guys final velocity is going to be what, 0, and u is what guys, we have already known now. So guys this will be tu, t up. So guys what we can say, we can say from here that t up is simply what guys, it is u divided by a. So u is what guys, it is under root of 2 a1 plus a2 into l divided by guys what, a, and a is what, a1 plus a2. So guys if we solve this, what we will get, t up is nothing but guys what, under root of 2l, let me put it in a better way, it is going to be what guys, 2l divided by a1 plus a2, okay. So guys if you see these two terms that I am going to just circle, okay. So guys if you see, this value and this value, guys, because the numerator is same. If you see the denominator, guys, this value is going to be what, this value is going to be smaller compared to this. It means what, guys, that this value is going to be what, bigger, and this value is going to be what, guys, smaller. Okay, so we can say that simply that t up, okay guys, is going to be what, less than t down. Okay, t down. So that would be what, guys, our answer for this problem, that when we are throwing the particle in the upside, then we will take less time to reach at the same distance compared to the time that we are going to take when it is going to come down. Okay, now it's your job, guys, to think about that, can we do this problem qualitatively also. Okay, means without using all these math that I have did, okay, I have done, can we do this problem, guys, qualitatively without like discussing about all these math. Okay, can we do this problem qualitatively also, means just thinking and understanding that what is happening there, and by the processing that idea, can we comment on this time thing. Okay, we don't need to worry about that how much it is greater than or less than. Okay, we have to just think about that it is going to be more or less. Okay, so this is your job, guys. Okay, so I'll put as a remark, okay, it is my remark, guys, that can we do this problem qualitatively also, qualitatively also, qualitatively also. So guys, if you can do that thing, please write down your answer in the comment. Okay, I would love to hear it. Okay, so guys, thank you so much. I'll see you in the next problem discussion. Okay.